These are the notes for part 1 of 2.2. We started this on Monday, October 25th. So in this example, we're going to analyze a graph, a real-world scenario, using increasing and decreasing descriptions of the graph. We're doing all kinds of analysis on this section, talking about different parts of the graph. And this one talks about a very real situation because typically when you have a high fever, you start graphing your temperature, right? That's what everyone does. Maybe not. I don't know. Probably not. But anyways, this describes it, and I think it's a really good example of increasing and decreasing because it explains it in great detail. So starting out, looks like this person had a temperature of 101. And if ever I get a graph like this where they use a different unit of measurement on the bottom, on the x-axis, I'll make notes for myself so I don't mess up. So at first, at 8 o'clock, notice it said right there, you have a 101. So that means at 0, right here, 0 is 8 o'clock. 8 a.m. And notice on the x-axis there it says hours after 8. So naturally 0 would be 8, which means 1 would be 9 o'clock, 2 is 10, 11, 12, 1, 2, and 3 p.m. So hopefully that helps understand. Always make sure you ask questions about the graph, like in your head. What do these numbers mean? And those are not times. Hopefully that gives it away with the 0. All right, this starts out with a decreasing picture because this person's temperature is dropping as we look at 8 o'clock till 11 o'clock, or 0 to 3. And they noted it right there. That's where it's decreasing. If we look at the second graph, it starts to rise. They describe it as maybe this person is exhausted and they are sick, so their temperature starts to rise at 3 hours, which is 11 o'clock, and it keeps rising until 1 o'clock, 5 hours after 8. So on this purple section right here, it is increasing. We're reading this thing left to right. And then lastly, looks like the temperature levels off at 100 degrees. So that's at 5 hours after 8, right there, until 7 hours after 8, which is about 1 to 3 o'clock in the afternoon. And they note that right there. So this is how I do it. There's some fancy notation right there that I just circled. I typically will write something like this. And as long as I can figure out what you're referencing on the x-axis, you're safe. So you can do this with parentheses. You can do it with less than signs. I see this thing as increasing from 3 to 5. So I typically write it like that. I see this thing as decreasing from 0 until 3. Some people ask about or equals because I do see solid dots on there. Let me erase my purple line. So I do see solid dots, meaning it does equal a value there. But to keep, like, just follow the rule, do not use or equals when describing increasing or decreasing. Because all we're doing is we're saying what is the behavior of the graph in a interval of numbers. We're not talking about whether it like equals something. So I never use the symbol or equals. In other words, I'm not going to use this or this. All right, it is constant from 5 to 7. Hopefully that makes sense. We're going to look briefly at min and max. Oh wait, no, sorry. We're going to practice increasing, decreasing. So on your paper, do a quick sketch of that graph, although I gave this as a handout. Hopefully you have it. And write the words again, increasing, decreasing, and constant. And maybe hit pause on the video and see if you can figure it out. I would say it is decreasing on these purple segments, and it is increasing. What other color stands out? On the red segment. So right here for increasing, I'm going to say it's increasing from 0 until 2. It's decreasing, starts at like negative infinity. It's an ugly infinity. Let me try again. And then it stops at 0, like it turns. But then it starts decreasing again at 2. It's not constant ever. Hopefully that makes sense. Let's try the next one. Feel free to abbreviate. As long as I can figure out what you're describing, that's fine. All right, let's see. I would say it is constant. Maybe hit pause before I do it and try and do it on your own. But I'm going to do it right now. So here we go. Constant on the purple. And it is increasing during the red. And it's not decreasing. So go ahead and write that one. Doesn't apply. Increasing, it starts at 0 and goes forever. I'm struggling with infinity. There we go. And it's constant starting at negative infinity and stays constant until 0. All right, now let's try min and max. And I basically just introduced it. I did want to, I told people on their graph to continue this line. That's ugly. Continue this line up and continue that line down. I feel like it makes the word relative more important. And you're supposed to identify with a coordinate where the minimum is and where the maximum is. Keyword relative minimum, relative max. So at first glance, I would say it doesn't have a max or a min because this graph is going forever up. It's never going to stop. It's going forever down. It's never going to stop. But notice they use the word relative. What that means is, can I chop this graph up and say it has a minimum in a section of the graph? So for example, if I chop this graph in half, like that, then we have a relative minimum right there. If this was a real problem, we would write the coordinate down. We have a relative maximum on the right half of the graph. So those are two things that we will be looking for on later problems. That's all we did for notes today. I will see you in class.